Okay guys, 1.5 is about exploring angle pairs. It's a bunch of different kinds of angles we're going to talk about in this chapter, so I kind of listed them out here for you already so you can see them all together, and I'm working on my handwriting, so it's trying to get better. But adjacent angles is the first thing we're going to talk about. Adjacent angles by definition are two coplanar angles with a common side, a common vertex, and no common interior points. So what that's saying is that when you're looking at the angles, take angle 1 and angle 2 here. Notice how they have this common right here. Okay, that's the common side. So with that side in common, angle 1 and angle 2 are adjacent angles, just like angle 3 and angle 4. They have no interior points that are the same. The next type is vertical angles. Vertical angles are just angles that are what they say vertical or across from each other. So in this case, angle 1 and angle 2 are vertical angles. Okay, so there's your vertex. They are across from each other. Complementary angles are angles whose measurements add up to be 90 degrees. So if I take angle 1 plus angle 2 here, it's going to give me 90 degrees. And so that's complementary angles. Supplementary angles are angles whose measures equal 180 degrees. So if I take angle 1 here plus angle 2, it equals 180 degrees. Now, complementary angles and supplementary angles don't need to be touching. So like angle 1, angle 2 here are adjacent angles. They don't need to be adjacent angles. If you have two angles out in space somewhere that when you add them up they equal 90 degrees, they're complementary, and likewise for supplementary. The next important fact here is that's postulate 1-9, which is called the linear pair postulate. And what that states is that if two angles form a linear pair, then they are supplementary. Well, what's a linear pair? A linear pair simply means a line. That's why it's called the word linear. So if you look at two angles that form a straight line, apologize for writing. So if I go here, angle 1 and angle 2 are a linear pair. They form this line right here when you put them together. Problem 1 is about identifying angle pairs. If you look at the picture drawn here, or actually taken a picture of here, you'll see multiple angles in the picture. I hope you can read it. Angle AFE is 62 degrees, EFD is 118 degrees, and BFC is 28 degrees. So if we're looking at this here, they want to know, are angle BFD and angle CFD, are they adjacent angles? So if I'm looking at BFD, let me get a red pen up here. If I'm looking at BFD, which is this angle right here, and I'm looking at CFD, which is this angle right here, are they adjacent angles? Well, see how this angle is here, and then BFD is all through here? Notice how they share the same interior points right here. Therefore, they are not adjacent. Okay, if you look at B, what B is asking is, are angle AFB and angle EFD, are they vertical angles? Okay, so let me erase this off here. So we talk about AFB, AFB, and EFD, EFD. Are they vertical angles? The answer to that question is, if they're vertical angles, is no. If you can take a look here, let me grab another color off here. AF and FD are definitely opposite rays. But is EF and EB, are they opposite rays? No, so they are not vertical angles. Okay, the last part of this is angle AFE and angle BFC are complementary. So if we look at those two angles, angle AFE, which is 62 degrees, and BFC, which is 28 degrees. So is 68 degrees plus 62 degrees and 28 degrees equal to 90 degrees? And of course the answer to that is yes. So they are complementary angles. Okay, problem 3, and as you'll notice we'll skip problems, so I went from problem 1 to problem 3. Just want to highlight the most important problems from each chapter. Problem 3 is about finding missing angle measures, if I can talk. Angle KPL and angle JPL are a linear pair. Measurement angle KPL is 2x plus 24, and the measurement of angle JPL is 4x plus 36. Find the measurement of angle KPL and measurement angle JPL. Now, as you'll notice, they're talking about angle KPL and JPL, and they say that they're a linear pair. So the first thing I want to do is always in geometry is draw a picture. So if I'm drawing my picture here, that's a line. Okay, it doesn't really matter where you put the other angle, but I'm going to draw a ray through there. That's going to be my angle. Notice how the vertex of both angles is P. So what I'm going to do is I'm going to put P right there. Okay, so we have KPL, and JPL that way. Now it says KPL is 2x plus 24. And it says JPL is 4x plus 36. So it helps me to see what's going on here when I draw my picture. And I could tell that KPJ is a straight angle. So the measurement of this whole thing here is going to be 180 degrees. So as I work to solve this problem, what I'm going to do is I'm going to take 2x plus 24 plus 4x plus 36 and set that equal to 180 degrees because they form a linear pair. It forms a line. So what I'm going to do, combine like terms as always. I get 6x there. 24 plus 36 is 60. That equals 180. Subtract 60 from both sides. I get 6x equals 120. Divide by 6. I get x equals 20. Now again, I can't overstress this enough. As I go here, it wants me to find KPL and JPL, not x. Now I need to find x to get those, but my question is I need to find those two angles. So I'm going to take 20, I'm going to plug it back in here, and I'm going to plug it back in there separately. I probably should have drawn the line over here, sorry. Let me correct that. I'm going to take that x and I'm going to draw it into KPL there, and then I'm going to take that into JPL. So 2x, or 2 times 20, plus 24 equals 64. 64. And 4 times 20 plus 36 equals 116. So there's my two missing angles. KPL is 64, JPL is 116. Problem 4 says ray AC bisects angle DAB. If the measurement of angle DAC is 58 degrees, what is the measurement of angle DAB? So again, stress this one more time. In math, we draw pictures. So I'm going to draw an angle. Doesn't matter what your angle looks like. There's my angle. That's angle DAB. Okay, so there's my angle. It says that ray AC bisects it. So AC is going to be right there. The word bisects means to cut in half. So angle DAC is going to be congruent to angle CAB. That's what it means, cut in half. They tell me that this right here is 58 degrees. So in other words, since it bisects the angle, this part right here is also going to be 58 degrees. So to find the measurement of angle DAB, all I'm going to do is take 58 plus 58, and I end up with, I believe that's, 116. Top of my head.